Hello everyone. Hope you people are doing fine. As you all know, I'm Gaganaji wearing USN 1V19 MT005, studying at Sri Venkateshwara College of Engineering, Department of Mechatronics. Now I'm gonna give an internship presentation on special purpose machines under the internal guidance of Mistress Ramya P, Assistant Professor, Department of Electrical and Electronic Engineering, SVCE, and external guidance by Mr. Gururaj S. Kampli, Senior Design Engineer, BFW Limited, Bengaluru. Now, these are the contents that I'm gonna cover about the company, company profile, introduction, task performed. Under task performed, we would see special purpose machine with 5 axes, analysis of structure of column, and about the spindle, and last comes with conclusion and references. Now, let us know about the company. Here, BHARAT FRITZ WERNER Ltd is basically known as BFW, India's leading solution provider of machine tools, manufacturer of horizontal machine centers, vertical machine centers, and horizontal turning centers, and vertical turning centers, multiple process technologies, 5-axis simultaneous machines, special machines, and customized solutions. BFW, a flagship company of Qatari groups, was established in the year 1961 with the collaboration of Fritz Werner GmbH Germany, and it also consists of 45,000 plus installation across the 18 countries, and BFW is operational at 15 countries through channel partners. A sales and service network is available at 48 locations in India with 5 tech centers and dealership networks. So, with an excellent design engineer capabilities and 2 state-of-the-art manufacturing plant, BFW is providing solutions to meet the performance, productivity, and reliability and expectations of diverse industries, such as aerospace, automotive, and dye mold, forging, valves, and railways, etc. To ensure companies' progress at every step, BFW has been continuously investing in R&D and has launched Dr. Kalam Center for Innovation in 2016 to create applied R&D for next gen manufacturing technologies. BFW has been recognized innovation awards, so it has been chosen for more than 600 companies across the nations. Incorporated M2 Next Solutions, a wholly owned subsidiary of BFW for addressing future manufacturing needs and to enable smart manufacturing. So incorporated BAMPL, a wholly owned subsidiary of BFW for addressing solutions for complex parts manufacturing. So now let us start with the company profile, where in order to meet the performance and the reliability and that other requirements of industries such as aerospace, automotive, die mold, forging, valves, and railways. So BFW is a good solution for all those things. So BFW has been constantly investing in R&D to guarantee customer progress at every stage. In order to like first apply for R&D, it's like newest manufacturing technologies, and it is basically is established with Dr. Kalam Center for Innovation in 2016. Now let us see some few of the milestones of the company. So Bharat Forge Warner Limited, it just began in the year 1961. The first product was a knee type milling machine. The I could say that industry's 4.2 automation solutions is by M2 Next, where the announced only a subsidiary M2 Next solutions for all the smart manufacturing. And in early 90s, the BFW became a very serious SPM manufacturer, supplying cylinder blocks and cylinder head transfer line. And recently we celebrated the 60th anniversary in 2021. Here we continue with our company profile. Like there is so many excellence that has been covered with BFW, including Kotari groups. So the one of we could see like few listed excellence over here. So just like HMSI award for machinery in the year 2005 and 2006. So it's a best stall award at IM Techs in the year 2001, and automotive axles Mysore award, that is basically known as like a gold award for the best machine to supply for the year 2018. And we could see that a Kirloskar Ferraz special award in the which was again in the year 2013. And lastly, so BFW has been recognized as one of the top 25 most innovative companies in India at the prestigious CII Industrial Innovation Awards. So this like there are many mottos that BFW would follow. Like this is one of the motto that our mission is to have completely pleased clients while maintaining a leadership position in the field of automation. So let us start with the introduction. So basically we would see about the overview of machine tool. So here we start with manufacturing is an industrial activity which converts the raw materials into useful product. So derivation of the word manufacturer means like with the hand. Due to the hand tools low capacity for a small process, now the manufacturing is predominantly performed by the use of machines. So manufacturing technology involves all the methods for shaping the raw materials to the final products. So metal cutting machines incorporate higher precision compared to metal forming machines. Example like extrusion and rolling machines. About 70% of functioning manufacturing machines industries are made up of machine tools. So development of machine tools has started with the creation of cylinder, which was modified to a general bearing with the roller assistance. Um, so it like we could consider like prehistoric Egyptians used to take technique for carrying pebbles for a quarry to construction site. And we could also see that machine tools delivers good quantity and quality without requiring highly specialized labor. It will minimize setup, which has been a major difficulty in the manual processes because machine tools are semi-automated or automated. So product differences are small, allowing for production of identical final items. And the machine tools have gained popularity due to their agility, reduced production time, and improved precision among the other benefits. Now let us see with the machine tool general requirements. It is just it's like what are the general requirements to manufacture any of the product. So general requirements reduce future machine difficulties such as structural deformation, vibration, wear, tool distortion, and so on. And like providing structural and joint stiffness will limit the danger for structural deformation. So a vibration will be reduced if appropriate dampening of capacity is provided. And like tool maximize profit speed and feed must be increased. However, this will have a significant impact on wear due to sliding components, and tool distortion may occur. So we have to reduce that by peak cutting time. So convenient design also involves cheap maintenance, repair and a production cost. Now let us start with horizontal machining center. It basically this company provides different kinds of machining centers like horizontal machining centers and vertical machining centers at and like special purpose machines and different machines that would be delivered to the customers as per the customer's requirement. So this is one of the machines that we would provide. So horizontal machining center with a cylinder milling cutters, disc cutters and angle cutters, forming cutters and other tools. The horizontal milling machine is type of machine with the spindle parallel to the work table, as we could see that it would be directly placed in a way that we could see directly from, it will be opposite to us. So and the fixture will be under that. It is used to treat different planes, inclined planes and grooves. The horizontal mills is the greatest option for finishing major projects with highly heavy materials and cutting one or more grooves, creating slots, and working on many other slides and materials. So this would work with different many angles. Now let us start with vertical machining centers. This is other type of the machining centers that the company provides to as per the customer's requirement. So the multi-purpose, highly adaptable vertical machining centers can also used for boring, threading, and drilling. So in addition to milling, the ability to execute mechanical operations, the availability of wide range of tools in changer, and abundance of possibility to boost production, like all these are kind of advantages for us. So the structural layout of CNC vertical machining centers makes it easier to fix the work parts. Additionally, because operations need to spend less time setting up and configuring the equipment, so it makes operation much simpler. The open visibility of the piece of equipment make it suitable for complex and huge manufacturing tasks and call fewer quantities. So we would prefer this VMC when the operations are quite easy. When compared to horizontal machining centers, there the cutting of tools or any cutting of products will be quite complex when compared to vertical machining centers. Now let us start with special purpose machines with 5 axes, where this is the machine which consists of 5 axes, one in the horizontal and one from the vertical, the other from which would rotate in this manner, and the other one which will tilt to 12 degree. So and like basically it is known as like XYZ, the linear axis, and like in the way that one moves in a horizontal manner, the other moves in the y-axis y manner, and the other one moves in a z like towards this manner, and the other one, it the fixture will rotate like 360 degrees, and the other one where it would tilt like 12 degrees apart. So here the 5 axis fully automated special HMC machine. Here this machine would be like horizontal machining center that produces a variety of front axle beams, where we could see these front axle beams where in the trucks or any lorries that would be fixed behind where the two wheels are is used to hold the two wheels and in a single setup. So this purely unmanned operations makes it easier for customers to use. With the 5 axis machining centers, the tool can rotate about A and B axis to travel across X, Y, and Z, the linear axis allowing the cutters to approach the a workpiece from any angle. So different from five-sided machining is 5 axis machining. Consequently, so CNC machining services enables limitless potentials for manufactured products. So you could see that basic features of special purpose machines with 5 axis would be the length of component between is 1000 to 2500 mm, and the complete robot deburring where it just automate itself, where only we have to give it the inputs or the products which is forced, so it automatically do all the operations as we given with manually written codes. So where it would take up like 10 for each cycle, and machine aided pin deburring and the kingpin and the quarter, and the parametric program for variable models, so plus 1 degree kingpin angle. So let us see with so this is the 5 axis machine looks like. So this is the front axle beam where it would be placed behind the lorries or any trucks, or it would be present even in the some trains to hold the wheels. So let us see the working of this. Like this comes like um, where the input will be given. So like the input will be the kind of forced products that would will be received from the companies as per the requirements. So here so we would place that in the left side, where all the products will be kept, where manual, like it is just basically forced. So this is the clamping. Just a minute. So we could see here that here we would just place all the products, forced products, and this is the clamping and unclamping, unclamping and unclamping device, where this is the gantry that is placed, and this is the exact machine where here inside that the the HMC is placed. With HMC in the sense it is a position where the spindle is placed, and here exactly the inside this exactly where the operation takes place, and this would be the where they could place the complete after the product is complete. So here, just as we have seen that here all the forged materials are kept. So once the product is kept, we could not rectify whether like the clamping is done at the proper exact position. So as we have the clamping is done, it just goes up, and it would just go and keep it in a separate place where to just adjust the proper position, where to keep the exact center position. So as per the manually written code, that would be simultaneously running in this machine. So we just to calculate the position, like the error that where the machine is clamped. So as the error output is given through the MOP, so it just directly give the instructions to the clamping device. So as it is clamping device again just goes in a separate position, and it would try to readjust the position, like to exactly know the center position, and then it just goes. Then the product will be lifted through gantry, where the gantry has a rack and pinion operation, where it just try to lift this from here, and this it just goes this way, and just put it inside this where the spindle is positioned horizontally, and the product that is for front axle beam will be placed on the fixture, where it would clamp the tighten. So all the operations will be done according, like drilling, tapping, and other kind of operations will be done as per the requirement. So once the while the operation is taking place inside this process, so simultaneously the products, the averaging of length would be taking place simultaneously because it is coupled. So here, I can see that here uh, um, the measuring will be taking place, and the operation that it is given by the customer. So everything will be returned by the ladder logic diagrams or CNC codes. CNC code in the sense M codes or G codes, just to move and to rotate all the instructions as per to run the machine and to get the output. So it will be simultaneously running as it is coupled. So once the operation is done on a particular product, so here the clamping device would hold one of the product, and this just directly goes there. First it tries to unclamp the product which is already placed in the fixture, so it would just try to pick that up, and just like the forced object that will be replaced again, so that the like already operated product will be kept on the conveyor, like output conveyor, so that the operators can remove that products out of that. So this working principle just works simultaneously until all the products would be completed. So these are some specifications where it is divided into 5 axes, like x-axis, y-axis, z-axis, a-axis, and b-axis, where the stroke for x-axis would be 2000 to 2500 mm, and for the y-axis would be 500 to 1000 mm, and z-axis would be 500 to 1000 mm, and there would be no stroke for a and b axis. And actuation for all the axes would be done by CNC, and the movement that would go by using like ball screw and nut assembly with the servo motor driving, and ball screw and the nut assembly with servo motor driving. And for the z-axis, it would be by AC servo motor through ball screws and nut direct drive. And the axis motor for all the XYZ axis would be by AC servo motors, and the rapid rate would for all the XYZ axis would be like 30,000 to 40,000 mm per minute, and the feedback that would be by a linear glass slide that would be 1 to 10,000 mm per minute. And the type of guideways that we use for this axis would be like rural guideways, where it would be in the type of like rollers. We could see that the movement like in kind of like roller things. So maximum kingpin angle would be for that b axis would be 10 to 15 degrees, and the table application for a axis would be like for fixture tilting, and for b axis would be for a cradle fixture with rotatory support table. And the angle of rotation, as we could see that a axis that would rotate in this manner would be 360 degrees. The purpose for all these axes would be for x-axis it's for column units, and for y-axis it would be vertical slides, and for z-axis like column units like in such a manner. And a-axis would be like below fixture, and b-axis would be for component indexing and fiber making. So these are few of the spindle features that would be useful in this. So this is uh, could see that the spindle unit where like the future features are spindle unit, fixture, coolant system, and chip disposal system, tool magazine, electrical parameters, lubrication systems, and CCTV cameras, tool breaker sensors. Where spindle unit is used for HSK, and A100 is a taper type. It is a taper type, and they use an AC spindle motor, and the stopper gearbox serves as a drives for the spindle. And it is just that we could go with the fixture. So it's a hydraulic fixture are employed. There is only one fixture in use. So for the fixture like and the gantry is used for clamping and unclamping components. And the coolant system is that it's a blood flushing, and through coolant systems utilize the coolant system. The type of coolant used for cutting is a water based emulsion coolant, and the coolant system's tank capacity ranges up to 800 to 1000 liters, and the pump utilized in centrifugal pump. The coolant is fed through the spindle using the through and the ring tools. We could see that in a spindle there will be no like through all the ring tools. We and like automatically we can't place a tool if there are any chips are found in that. So it just basically put off the coolant, so just take it off like all the chips that would be present in there. And the chip disposal system, it's a kind of slat type, and is used to transport the chips from one place to other place. That would collect everything which is already dumped in the inside the machine. So we should have to remove all the chips so that it would work fine. And the tool magazine is that it is HSK 100. It is a type of tool magazine used, and we could there is a automatic tool changes where it is placed of 22 tools in one magazine, and it's a both random and bi-directional. It could also move in a one direction and the other direction too. And the electrical parameters that we would use here, this is a primary supply of 415 volts AC and 10% of surge and spike free, and it's about 220 volts in a control voltage for contractors, and it's we use about 24 of solenoid voltage maintained, and 150 kilo kVA is the total connected load, and CNC is the preferred method of machine control for both machine and the gantry. And we could see that lubrication system is entire machine. It will be lubricated by progressive lubrication system, and the tank capacity is about 10 liters, and the gantry general lubricating system is maintained using a rack and pinion gear. as a lubrication system, like it just works based on the proximity sensors, where exactly like we can't just keep on supplying the lubrication for all the parts, so that based on the proximity sensors or other sensors that would place in a particular place, so based on that it would sense and give the suggestions to the progressive lubrication system, so it would directly supply the like lubricating oil to particular place. So like we could we could also like remove the coolants from the oil by using the oil skimmer, where it just keeps on swirling, so the oil just regenerates in separate place. And as like just now told about the oil skimmer. And so CCTV camera would be placed inside the machine, so that if any damages would occur, so that the operator can easily visualize that from outside, and if any malfunctioning is done, so he can just kind of what it can kind of like stop or can operate in such manner. So it's a tool breaker sensor. Tool breaker sensor is an exam into reliability of tools and ensure high quality products with minimum rejects for machining times are necessary for mass production of mechanical parts. So tool checks must be completed as it's feasible, and it's quickly inspect solid body concentric like instruments like drill bits, tapping tools, and flats and ball and milling customers for breakages. So these are some additional features where gantries for auto loading and unloading of components. It's a kind of two-stage component conveyor, where it would the input forced materials will be taken in one conveyor, and it would just directly clamp somewhere where exactly the product is placed, but it is not exactly as per the given length. So it would be placed in the another stage of the conveyor, where it could directly like try to solve the errors. So here in the linear glass scale of XYZ axis, as we could see that the roller would be in the kind of guideways, and the Renishaw touch probe is a probe that would help us to find the length of any product, and it's an emergency safety circuit. It's made up for any of the malfunctioning, and it would let us know like how where exactly the malfunctioning is going on. The gantry power supply module, like it is where the component will be clamped and unclamped, and filter paper, as we could see there, as we there is lot much of chips will be present there, and some of the um, uh, like oil will be there, so everything will be filtered. So dirty tank and the clean tank, where the coolant will be placed in a dirty tank first, because like most of the chips and other lubricant, it will be mixed with the lubrication, and it by use of some mechanism, it would the coolants will be made it as clean, and that can be reused. And RS-232 and USB ports are used to insert any of the codes or any of the instructions to that must be given by the to the machine. We could just directly insert through a like USB port with some what is that memory card. So automatic tool changer is that basically we can't do one particular operation with using one tool, so we use automatic tool changer, where like 24 to 32 tools will be placed. So as per the requirement, the tools will be directly exchanging to perform the operation. And it's a main operating panel is that it is where exactly the operator would try to monitor the functioning of the system. And analog input modules, where the inputs will be given as an analog, like we have seen that voltage supply or any other current supply. And scale detecting unit, so it would help us to detect the scale, or like the measurement, or like how the movement of particular product. And the feedback through encoder, as we could see that there is a proximity sensor placed inside the encoder. We could just get the feedback through encoder, as once It is directly goes near to the proximity sensor, and it's a rear chip conveyor pendant, as we have already like studied about the chip conveyor, where it just directly transfers the chips that is um created while doing operation. So it would be like transfer from one place to another place. So like these are the components used in the five front axle beam. This would be in the machine, and this is the fixture that would look like, and these are the kinds of toolings that can be placed by using automatic tool changes to do the particular operations. And this is the gantry system and automation, where the product will be moved by one place to another place, where the clamping and unclamping will be done. So this is a deburring device where exactly the product can be holded, and this is like kind of process design where it would be done by the operators. And let us see with the advantages. One 5-axis machine can complete all the 5-axis manufacturing work, saving a lot of time by doing such need to prepare a clamp and configurations. So processing of complex geometries is quite simple, and it's a simultaneous assurance of high productivity and efficiency is possible. So it is possible to create excellent surface finishes which increase the overall quality of 5-axis parts, and it would help us to have the greatest improved accuracy and increased capabilities, and increased throughput and reduced lead time, and improved cutting conditions and maintenance of optimal cutting and reduction of tool damage. These are limitations of 5-axis beam machining. So costs are quite excessive, and operators requires a high level of technical skills and programming that is difficult and complex. So as I've told that it would be placed just to hold that wheel. So here is a front axle beam look like. So this will be placed in such automotive vehicles. And there is another like tractor components. Under tractor components, we could also find a different kind of front axle beam. So like it was just a basic of using a SolidWorks. So we have just taken a small like they have to give an example using a small column that is used. This a vertical column where other operations will be done. So it's just a structure of column that would be placed in VMC machines. So now like we just tried getting the values of stress, strain, and displacement by using the software called SolidWorks. See how the column component is designed during the SolidWorks software, and this component is required to hold our motor, spindles, or any other electronic components for the machine to perform different operations. And the component made by and this component will be made by gray cast iron, and the behavior of column is studied by performing some static analysis on it. So SolidWorks is a simulation is user-friendly set of structural analysis tools, simulates and CAD models where any of the students or any of the designers could use that to just to have a static analysis on a component. So it's a finite element analysis to predict a product's behavior in real world. So static, non-static, and dynamic analysis are also capabilities offered by this portfolio. This is how the like stress component look likes. So it is basically using with the machine of the columns. So we could directly have a considering a column, we could see that it can like mass is up to 2488.87 kgs, and its volume is about 0.345677 meter per cube meters cube, and the density would be about 7,200 kilograms per meter cube, and weight would be around 24,390.9 newton. And we could also see that some other properties where and here this looks like how the displacement when we put on some weight on the top of the surface, and a meshing will be done. So after meshing will be done, like we would try to do the analysis. So for the stress, the component look would look in such a manner, and for the displacement we could see that kind of the red portioned area is where is a portion where it is the load is much more. And this would be the strain diagram, as the zero strain temperature would be around 298 kelvins, and its incapable bonding options will be around automotive. And we can see that by considering the units, we would go for SI units, and the length and displacements would be in terms of mm, and temperatures would be in terms of Kelvin, and angular velocity in terms per radians per seconds, and pressure or stress would be in per terms of Newton per meter square. So here this is another type of the meshing information would be around its solid mech. The measure used is curvature based mesh, and it's like Jacobian points for high quality mesh is about 16 points, and maximum element size is around 190.1741 mm, and the minimum element size is around 38.1482 mm, and mesh quality is very high. So as we could see from the above study of the column, like for a fixed area of LM roller guideways, a rail and the force of 55,000 Newton is applied for that. And here are the results that we have found. By maximum stress is around 7.626 to the power 6 Newton per meter square, and minimum stress is 6.54 to the power 1 Newton per meter square, and displacement is around like the maximum displacement, it was 3.754 to the power minus 2 mm, and minimum displacement in terms of 1.0 to the power exponential 3 in terms of mm, and strain, maximum strain is 7.585 to the power 5, and minimum strain is 2.802 to the power 8. And we could see that like analysis of column component is studied. And then so let us see about the spindle. Here the spindle is known as heart of machine, where because all the operations will be directly dependent on the spindle, like many of the operations like drilling, tapping, forging, and most of other operations will be directly dependent on the spindle. So it is common to refer to shaft at the center of the machine, where it would be placed horizontal in terms of HMC and vertical in terms of VMC, and its axis tools rotating axis of a spindle. But the term that is also refers to the entire rotary unit, including the shaft, its bearings, and anything attached to it. And its spindles rotate about an axis that receives command from the controller for the movement, and this essential part of machining centers is a spindle. As like told, its spindle form of it just used for cutting force and the speed, and spindles are available in the many of the numbers of configurations and to meet up the needs of diverse industries. A machine tool has biggest spindle, also it refers as a main spindle. So these are the types of spindles. So it is belt driven spindle, direct drive spindle, and gear driven spindle. So these are a few types of the spindles. First one comes with the belt driven spindle. It is where a belt drive spindle is a mechanical component of a tool, also known as the lathe, that aids in setting the material so it can be cut, deformed, or nulled, and used for the other potential activities to help construct an object. So then next comes with the direct drive spindle. Here this allows a bigger processing area while having the higher torque power and faster, more accurate, and activation is like more. And the gear driven spindles, is power is eventually transmitted because gear spindles maintain constant angular velocity at misalignments of angles. So, like, I would like to conclude my internship with it's a best experience at BHARAT FRITZ WERNER Ltd and was very valuable. And this is this internship was just fantastic opportunity for me to have the hands-on experience, and it made me to have skills on the working of machining the huge machines like HMC, VMC, and by knowing about the ladder logic diagrams and about the CNC coding. And by my time at BFW Limited has been an incredibly rewarding and enriching experience. From obtained results from analysis of structure, like I would conclude, and study of a special purpose machines are performed. So through my internship, I was also able to learn how spindles are made and how they work in HMC and other VMC machines, as well as like how electronic components are used in machines and how they work to run them. And it is necessary to understand like how to code and platform that is used to construct it, because the machine fundamentally runs using the CNC coding and ladder diagrams, as we have seen that the ladder diagram that we used here by the fan, it was given by the Fanuc. And I'm grateful for the opportunity to work with such a talented team and look forward for applying what I have learned in my future endeavors. So these are the reference papers and the catalogs that we have referred for this analysis in my internship. So